Okay, so we're going to have a little look at what happens with pressure in liquids today. So I'm on page 132 in the notes. So open up your notes there and fill in the notes as we go through this. And remember, you can pause me to, if I end up filling things in too quickly, pause me and make sure you are writing down what I am writing down in mine, okay? Okay, so if we were in school, we would have been having a little look at this demonstration, and I'll have a wee nosy. I'm sure there's a video on YouTube I can link for you for this to show you what goes on here. But this is a spouting can, and it's maybe not 100% obvious from the picture, but this is really just like a big cylinder with water in it, and there's wee holes in the cylinder at different points. Okay, now this is to demonstrate what is actually happening with pressure in liquids. So if you think back to the pressure formula, pressure is force divided by area, then the bigger the force that's acting on something, the bigger the pressure. So if you think about the water that is down at the bottom, the very, very bottom of this can, then it has the weight of all the water up above it, acting on it, pushing down on it. So that's a pretty big force, which means that the pressure is way bigger down at the bottom than it is, say, up at the top. Because if you think about the water that's at this level here, then it only has the weight of this little bit of water above it acting on it. So that means the pressure up here is way less than the pressure down here. Okay, so hopefully that makes sense the way I've explained that. And what this demonstration does is it actually shows what happens with the pressure by the water that is shooting out of the can. So at the very, very start of the demonstration, whenever I would fill this with water and I would cover up all the little stoppers, whenever we take the stoppers off, then at the bottom, because the pressure is really, really high, the water goes shooting out really far. Okay, so it shoots out quite the distance horizontally. The water that's coming out of this middle one is sort of going to be a bit less than that, because remember it has less water up above it. So it's going to do something like that. Okay, and then the water from this one here with hardly any water above it, weight of the water above it, so the pressure is really low, is going to come out something like that. And what we would have talked about in class would have been that as the water level decreased, then you would see, so let's look at this one here, you would see the stream of it coming less and less and less in, because as the water level decreases, the weight of the water, the force is decreasing because there's less water above it pushing down on it. So the pressure decreases and this stream of water will eventually make its way in. Now I don't think you'll have anything like that in your house, but if you do, give it a go. Try making something. If you have I don't know what you would have, drill a hole, not you drill a hole in it, get someone at home to drill a hole in it and see, can you actually make something that does this? I would love to see it. Okay, so let's fill in our questions. From which hole did the water travel furthest? And the pressure of the water must be greatest here. So it was the bottom one. And then complete the sentence. The pressure of a liquid increases as the depth of water increases. Okay, that's the first rule that we need to know about pressure in liquids. The pressure. The second thing to know is that pressure acts equally in all directions. So, where's my water pen? I would have got like a sandwich bag or something like that and poked some holes in it. And what that would have shown was that no matter what direction the hole was in, the water shoots out equally in all directions if the holes are all at the same level. So if they were like, if this was a really long bag with a difference in depth, then obviously this same rule from up above would apply. The lower ones at the bigger depth, they would shoot out further. But it's not like all the water shoots out to the right or all the water shoots out to the left. It shoots out equally in every single direction. So that's the two rules that we need to know about pressure in liquids. It increases with depth and it acts the same in all directions. So let's see, answer our questions. From which holes, if any, did the water travel furthest? All the same. And complete the sentence. The pressure of a liquid is equal in all directions. Okay, so over the page on 133, there's room here for us to fill in what we know about pressure in liquids. So we're going to write out the two main rules there. So first one, pressure in liquids increases with depth. The second one, pressure in liquids acts equally in all directions. And we also would have had a little look at one of the ways that engineers have to take this into account whenever they're designing and building things. So one of the things that we would look at would have been a dam, so like a water dam. And if you were to look at the design, and this won't show it properly, of a dam, it would be much thicker at the bottom than it would be at the top. So say this was it. Then because the pressure is way bigger at the bottom than it is at the top, the wall has to be much thicker there to be able to withstand that higher pressure. So that's why dams have to be designed like that. So the way we would show this is just to show that there's a much bigger force acting down at the bottom than there is towards the top. And we show the difference in the forces just with the different size arrows. Okay, so dams are built to be much thicker at the bottom than at the top to be able to withstand the higher pressure. So we will make a note of that here actually. Dams are designed much thicker at the bottom to be able to withstand the higher pressure. And that's because of that bigger force acting, because of the weight of the water up above it. So we're not going to be able to do this, but what you are going to be able to do is answer these questions on page 134. Okay, so I'm not going to fill this in now. I will fill this in for you to go through your answers for next lesson, and I'll be able to upload that with the next lesson. I'm also going to be asking you to submit this to me on Google Classroom, so I'll be able to have a wee nosy at your answers. Now I will have a wee look for the YouTube video with the spouting can, but also one that talks about pressure in liquids and how that affects divers, because that's quite an interesting wee video to watch. Okay, so hopefully that keeps you sorted for today. Pressure in liquids is very short whenever we're not doing the actual demonstrations. You can give those demonstrations a go if you can, especially this one with the sandwich bag, and poke holes in it, and you'll be able to get the you'll see the water shooting out in all directions. Just don't make a mess of your kitchen or anything. And this one here might be more difficult to demonstrate at home, but sure, if you've got time, why not give it a go? Okay, so I'll write my instructions about the homework and all that on Google Classroom for you, and let me know if you need any help. See you next week.